Okay, so now that we know how breadth first search works, let's talk about depth first search. Depth first search is a little bit more tricky because we have to keep track of all the nodes that we visited. And whenever we visit a node, we have to ensure that we visited all of the child nodes before we visit another node. So to give you a better understanding, let me show you the example. So now suppose here we have a structure, a tree structure that has letters in there. And in this case, we're trying to find this specific item right here, H. Let me show you how the depth first search will work. First, we're going to check A, okay? And we'll put A here in our stack. So imagine this is a stack structure here. And we're going to check the connections to A, okay? And we know that we have B connected to A. So now we visited A and we visited B. So we'll put B on our stack right here. Since we're at B, now we're going to check all the connections to B. And the only connection that we see here is D over here. So we visited D, we'll put D on our stack. But D has no more connections, okay? So we can't go any further here. So what we're now going to do is remove D from our stack. So we'll pop this off our stack. So after we pop it off our stack, we're now back to B, okay? So we're going to check any other connections to B. B has no more connections. So we'll pop that off our stack. And now we're back to A. And we're going to check if A has any more connections. As we can see here, A has a connection to C. So we're going to visit C, and then we'll put C on our stack. And then we're going to check all the connections to C. First one is E. So we're going to visit E, and then we'll put E on our stack over here. And since we're at E, we're going to check the connections to E. The first connection to E is this G over here. So we'll put G on our stack. And now we're checking the connections to G. There are no more connections over here to G. So we're going to just remove G off our stack. And now that G is off our stack, now we're back to E. So we're checking if there are any more connections to E that we haven't visited, which is this over here, which is H. So now we put H on our stack. And since the item that we're looking for was H, we basically found this item. So as you can see with depth first search, we're actually doing some type of backtracking where we are keeping track of each item that we visit. And then once all the children of that item has been visited, we pop it off our stack. And if you notice, we're searching depth first, so we're going in vertically. And we're not just searching level by level like we did with the breadth first search. So that's the main difference between depth first search and breadth first search. Okay, so just to make this a little bit more clear, we're going to try a different example, okay? And this time, we're looking for F over here. And hopefully you remember the steps of how to get to F. So let's start with A. Okay, so first we visit A, and then we push it onto our stack. And then we visit B, and then we push it onto our stack. And then we visit D, we push that onto our stack. D has no children, we remove that from our stack. And then we go back to D, which also has no children, so remove that off our stack. Now we visit C, so we put that on our stack. And then we visit E, and then we push that onto our stack. And then we visit G, and then once again, push that onto our stack. G has no children, so we remove G. And then we go back to E. E has one other child over here, which is H. So we visit H, we push that onto our stack. H has no more children, so we just remove H. And then we go back to E. E has no more children that we can visit, so we remove that from our stack. And then we go back to C. And as you can see, C has another child, which is F. So we put that on our stack, and we can see that F is the actual item we're looking for. Okay, so I'm going to give you a real life use case of how we can use depth first search to solve a problem. Imagine we're trying to design some type of navigation system, and our objective is to get from one point to another point. And we're supposed to find the path that we can take to get from point A to point B. So we can use depth first search to solve this problem. In this case, imagine we're trying to get from Russia all the way to Spain. And as you can see, each country here is connected to another country. And our objective is to find a path from this country, Russia, to this country, Spain. So let's use what we've learned about depth first search to solve this problem. So first, we're going to start at Russia, which is our starting point. And now we're going to find the connecting node, the left connecting node, in this case is Ukraine. And then we're going to visit Ukraine. So we've gone from Russia to Ukraine. So now we're going to check what is connected to Ukraine, which is Romania. So since that's the first connection, we're going to visit Romania. Once we get to Romania, we realize that we can't go any further. So then we go back to Ukraine. So we remove Romania from our stack. And then once we're at Ukraine, we're going to find the next connection to Ukraine, which is Poland. And then after visiting Poland, we realize that Poland only has one connection, which is Germany. So then we're going to visit Germany. And then from here, the next place we're going to go to is France. We've gone to Germany and we've gone to France. And now the next place we're going to go to would be Spain. And since this is the location we're looking for, we can stop our search there. At the end of everything, you will notice that in our stack, we basically have the order or the path that we're going to take to go from Russia to Spain. First, we go to Ukraine, then we go to Poland, then Germany, then France. And then finally, we arrive at Spain. So one of the things that makes depth first search even more interesting is we can remove one of the nodes or one of the items and the algorithm will still work, okay? So suppose there is some type of conflict going on in Ukraine, so we can't pass through Ukraine. In that case, if we removed Ukraine from Russia, instead of going to Ukraine, our algorithm will take us to Belarus, and then from Belarus to Poland. So then in the end, it will look like this. So hopefully this example will show you how useful these search algorithms could be.